Okay, in this video we're going to look at what is the law of sines formula, and then how to use it to solve a problem, and how do you know if it's the right kind of problem to use it on. So first of all, what is the law of sines? Well, it's a formula that works in any triangle, so you can have any triangle. It does not have to be a right triangle, and that's one of the quick answers to when would you use this. If it's not a right triangle, this might be the formula you're looking for, although it does also work in right triangles. This formula basically says, okay, let's call the vertices, the corners, the angles in this triangle, A, B, and C. Let's name the side across from A, the opposite side from A, lowercase a. Let's name, ooh, didn't mean to slide that over. Let's name the side across from B, lowercase b, and the side across from C we could call lowercase c. The law of sines basically states that if you take the sine of an angle in a triangle and divide it by the side opposite from it, right? So like sine of angle A divided by the side across from it, that's lowercase a, that would be equal to the sine of another angle, like B for example, divided by the side across from it. That would be lowercase b. Now notice that we could have also said that either of these could be equal to the sine of angle C divided by the side across from it, which would be C. It doesn't matter which particular side and angle you pick, it just has to be a side that is opposite from the angle that you pick. So in words, you could think of this as the sine of an angle divided by the side across from it is always equal to the sine of any other angle in the triangle divided by the side across from it. So that's what our formula is. You could think of it as, again, angle side opposite from it. That's the first half of your formula. And then you could do, once again, the sine of an angle side across from it. That's the other half of your formula. That's the formula, and that's the setup. Basically, if you know 3 of these pieces of information, you can fill them in and solve for the other one. Usually that'll be used to find a side length if you know 2 angles and another side. Let's look at an example. All right, so example problem. Let's just make up a triangle here. So here is a triangle. Notice it does not have to be a right triangle. You would usually use the law of sines if you know 2 of the angles. I'm just going to make up numbers. Let's call that 20 degrees and let's call that 30 degrees. Let's say we're trying to find this side, and let's say that we know what this side over here is. Let's call it 12. This is the type of situation where you will usually use the law of sines because we know an angle and we're trying to find its opposite side, and we know another angle and we actually know its opposite side, meaning we can fill in 3 of the blanks in our formula. So let's actually do that. We would have the sine of the 20-degree angle divided by its opposite side, which is the x, and that would be equal to the sine of the 30-degree angle divided by its opposite side. That would be the 12. So that's kind of step 1 here. Step 1 is fill in the blanks in the formula, right? So step 1 is just fill in the blanks in the formula. So we could even write those down. If we wanted steps, let's do that in black. So if we wanted a step-by-step process, step 1 is fill in the formula. But what's going to be step 2? Well, we've got to solve it. And I would recommend that you cross-multiply. Cross-multiply is usually going to be a good strategy here because that works when you have 2 fractions equal to each other. All right, so what would that cross-multiply look like? Well, cross-multiplication is where you take the bottom of one fraction and multiply it with the top of the other one. I'll make a video about cross-multiplying, probably separately. Maybe I'll put a link up here eventually when that video is made. So you could multiply those. So for example, we could have x times sine 30, and that would be equal to multiplying the other diagonal. Let me use a different highlighter color to highlight that one. So we could highlight this one. So we do this one. That is way too big of a highlighter. Let's use a smaller highlighter. Okay. So smaller highlighter. We could take this one and multiply it by this one. So that would be the 12 times the sine 20. But here's the thing, you could just type that in a calculator and get a rounded answer at this point if you want your work to look a little bit simpler. I'm going to save all the rounding until the very end and then put the whole thing in a calculator to get a little bit less rounding error. But here's the basic idea. That was your cross multiplication there, and then we had our cross multiplication right here. So you can use these highlighter colors to track down how that cross multiply worked. From here, we want to get x by itself, right? So we're going to have to divide by what x is being multiplied by to get rid of that, to get x by itself. So the inverse operation of multiplication is division. Let's do some division here. We're going to divide both sides by sine 30 to get rid of that and leave us with x is equal to, well, the exact answer is 12 times sine 20 divided by sine 30. That's the exact answer. And then if you want a rounded answer, which is what you would usually want, you would type that in a calculator to get a rounded answer. I'm going to do that now on my phone. Now, while I'm doing that, let's talk about how you do that on calculators. If you have a phone or a calculator that just does things one piece at a time, you would have to do 20 and take its sign, then multiply by the 12, get your result, and then divide that by sine of 30. So again, on like an iPhone or something, you would do 30 and then hit sign. On other calculators that you actually type the whole thing out, you can just type the whole thing out. Like I'm doing 12 times sine 20. I can just type that whole thing in, which is nice. I can get that result, and then I can divide it by sine 30. So I'm getting about 8.2. You always want to be careful on problems like this as well that you're using degrees and not radians if your angle measurements are in degrees, that kind of thing. All right, that's an example of how to use the law of sines formula. And let me know if you have any questions. You can use the comment section. If you're interested in more math help videos, take a look at my channel, hit the like button, subscribe button, and all of that. And I hope you have an excellent day.